Rationalize the denominator. Variables represent positive real numbers. This positive real numbers bit that they're telling us is important for us to think about for at least half a moment. The reason why we're writing this down is because in general, when I have a square root of something, let's call it x squared, this square root and that squared don't quite cancel. They leave us with an absolute value of x. We get to stop writing the square and the square root, so in some sense they cancel. But at the expense of getting rid of those, we have to introduce these absolute value signs. Well, if x happens to be positive, then the absolute value of x is just x itself. And so when we restrict ourselves into this realm of we're just using these positive variables, then this cancelization does just happen super nicely. The square and the square root cancel, and all we're left with is the x. If we didn't have this stipulation, we'd have an absolute value of x, and that would be cluttering up our page and stuff. And so lucky for us, we get to assume that we're dealing with positive things. So we want to rationalize this thing now. Rationalize just means get rid of the square roots that appear in the denominator. In this case, there's just one square root, and it's of a fraction. So first I want to rewrite this into two square roots and look at the quotient of those two square roots. Right? This is this rule telling us that if I had a square root of a fraction, I could go ahead and take the square root of the numerator and divide by the square root of the denominator. So that's all I've done here. So here's our denominator, square root of 5xy. That's the thing that we'd like to rationalize. That's the thing that we'd like to get rid of, that square root. The way to do that is to try and multiply this thing by something that makes the square roots go away. And in general, I erased it. I shouldn't have erased it. In general, we know that squared things and square roots cancel. So if instead of having 5xy under the square root, if I had, say, 5xy squared under the square root and the square would cancel. And to have something squared, that's just the same way as saying I'm multiplying it by itself. So really, the thing that I would like to multiply this by to get the square root to cancel is just another copy of exactly what I have. Right? And now I have a square root of 5xy times another square root of 5xy. And so by the rule similar to this one with products, square root of a product equals square root of one piece times square root of the other. I have here square root of one thing, square root of something else. I can go ahead and combine them under a single square root and just multiply those two radicands together. 5xy times 5xy is a 5xy squared, all under a single square root. And now that square root and that square are going to cancel for us. So that's what's going on in the denominator. And in the denominator, right, they're going to cancel. We're going to have exactly what we want, something without any square roots. Let's look at what happens in the numerator. In order to multiply down here by this thing, I'm going to have to multiply in the numerator by exactly the same thing, because all told, I want to be not changing this any. So I can rewrite it using rules, or I can say multiply by the number 1. And that's what I'm doing here. I have this 1, which is being represented by something divided by itself. So that's 1. I'm multiplying by 1. I'm allowed to do that. I'm not changing things by multiplying by 1. And in the denominator, it does these nice things that I like it to do. In the numerator, it does, well, whatever it does. I have a product of root 3 times root 5x times y. Again, I'm going to use this rule and just multiply the radicands together under a single square root. So I'll have 3 times 5, 15 times x times y. And that's what we get. You know, there's no factors, things squared in here to pull out of the square root. There's no addition to do or a multiplication that I can do to simplify things. So this is our nice final answer in as simplified form as we can get it.